This next section will just be the part about writing balanced equations from words. Maybe referring a little bit here and there because you really can't do this without your periodic table unless you're really good at names and formulas. So it's kind of like the skills from the old test. For instance, the first words that I knew was going to have to find iron. That's Fe. So when I come back here, I'm going to put iron. Burns in air. Got to remember that the thing in air that burns or that helps support combustion is the O2. This black iron solid is iron 3 oxide. They're talking about the kind of iron with a +3 charge. Oxygen is a -2 charge. Therefore, it's going to take 2 +3s with 3 -2s. This is a +6, -6. Fe2O3. Fe2O3. Okay, just 2 things. Balancing this, I'm going to count Fe's and O's, Fe's and O's. I think it's going to be the 1, 2, 2, 3. The oxygens are the classic 2-3 dilemma where we're going to need 6 on each side. So if I triple this side to get 6 and double this side to get 6, I ended up having to recount that, and that ends up with 4 Fe's. So I'm going to need a 4 in front. That one is the balanced equation. I don't need the little subscripts, the liquid solid gases. Magnesium hydroxide. Got to find magnesium on my periodic table. Magnesium, that's over here, and it's got a +2 charge. Got to find hydroxide. That's back here. It's an OH with a -1. So if I'm really trying to make magnesium with a +2 and OH with a -1, I'm going to need 2 of those. I've got to write that as MgOH2. And even then I got to be careful because that looks like it's just 2 H's. That's why I need these parentheses. Nitric acid, you weren't expected to know. Somebody just told you it is HNO3. It forms water, H2O, and magnesium nitrate. Magnesium, we just saw that. That's an Mg with a +2. Nitrate, I'm going to have to go looking. Find it. There it is, NO3 with a -1. There was kind of a hint that was it, but I didn't know its charge, so I went and looked it up. NO3 with a -1. Well, that means we're going to need 2 of those to balance off just 1 of those. So when I write this, I got to write it accordingly. Mg NO3, I need 2 of those, not 32 oxygens, so that's got to be in parentheses. There, it's written correctly. Now I need to balance it. When I count this, I'm going to count it as Mg's, OH's, H's, and NO3's. So that means I need some H's and OH's. It's okay to do this. You don't have to, but it's okay to count it. In fact, it's kind of preferable. I'm going to write it, though, as Mg, OH, H, and NO3. I write it in the same order so that I can go down the line and compare. Count them up. 1, 2, 1, 1. Versus 1H, 1OH, 1Mg, 2 NO3s. So what's the first thing that doesn't match? I would say the OHs. I got 2 of them over here, but only 1 of them over here. Maybe I'm gonna fix my NO3s first. It's just a gut feeling of where to start. I'm gonna double this. So I'm gonna put a double this so that I get 2. Now those match. But that also doubled this so that I have 2. 1, 2, 2, 2 versus 1, 1, 1, 2. I got twice as many of these here as here. So that's good thing is they're both in the same spot. I need double as many on the right-hand side or the product side. I do that, 2 and 2. That's balanced reaction. Next one. Iron. Okay, we just had that one. I don't even have to go to the periodic table. It's Fe. Solution of hydrogen sulfate. Hydrogen, I can find that on the periodic table. It's H+, +1 charge. Sulfate, search. There it is. It's SO4 with a -2. So hydrogen sulfate, that's SO4 with a -2. Well, 1 hydrogen can't get together with 1 sulfate and be happy. It's going to take 2 hydrogens for just 1. Apparently I need to write that as H2SO4. It reacts to form iron 2 sulfate. Fe with a +2, SO4 with a -2. That's a match made in heaven. FeSO4. No Roman numeral in there. The Roman numeral just told me what the charge would be. Finally, hydrogen gas. Not just simply H, but H2. You do not need to put the little L's or G's or AQ's. Time to balance this. I'm going to be counting Fe's, H's, and SO4's because they stick together on both sides. Fe's, H's, and SO4's. On the left, I see 1, 2, and one of those versus 1 Fe, 1 SO4, and 2 of those hydrogens. 1, 2, 1, 1, 2, 1. Looks like that's already balanced. I like that. On to the next one. Is there a next one? Last one. The combustion. Ooh, a combustion. The combustion of ethane gas, C2H6. Combustion, the only way things combust is if they react with oxygen. It doesn't tell you that. You got to be smart enough to know that. Or you got to put the time in and practice them. It's going to make carbon dioxide and water. Classic complete combustion because it's carbon dioxide. Once again, I'm going to count C's, H's, and O's. 2, 6, 2 versus 1, 3 oxygens and 2. First fix the C's. Double that. Don't even recount. Now fix the H's. Triple that. Now we recount oxygens on the right. Now I have 2 times 2 is 4, plus 3 is 7. And there it is again. I got an odd, and I got an even. So I double everything, except the oxygen. Save that for last. That's what we were doing. Double everything, except O2. I don't need 1 C2H6. I need 2 of those. I don't need 2 CO2s. I need 4 of those. I don't need 3 H2Os. I need 6 of those. Now recount the oxygens over on the right side. 4 times 2 is 8, plus 6 is 14. Now we have even and even. There should be something we can write right there that gives us a grand total of 14 on that side. Well, it was 2 times 7 is 14. That is balanced.